Yeah. In the previous class, we discussed about what ma? Variation of atomic radius in period and group. From top to bottom in a group, from left to right in a period, how the atomic radius changes we discussed. And today we are discussing about what the variation of ionization potential from left to right in a period and from top to bottom in a group. Okay. Suppose first what we are taking definition of ionization enthalpy. So ionization enthalpy or ionization potential, anyone we can say here. Ionization enthalpy or ionization potential or ionization energy. We can say IP or IE or delta IH. Anyone we can use here. Now we have taken example sodium atom, neutral atom of sodium. Now this sodium atom has electronic configuration 1s2, 2s2, 2p6, 3s1. Okay, how many valence electrons? One electron. How many outermost electrons? Number of outermost electrons, how many? One in third orbit. So in first orbit, two electrons are there. 1s2, two electrons in first orbit. 2s2, 2p6, 2 plus 6, 8 electrons in the second orbit. And one electron in the third orbit. One electron in the third orbit. So outermost electron is what? No, one. Number of outermost electrons, how many? One. So this one electron, if you want to remove from the sodium atom, we have to supply some amount of energy. So the energy required, the minimum quantity of energy required, the minimum quantity of energy required to remove the electron from the outermost orbit of a neutral atom in its ground state. This atom is not excited atom here. It is the atom in ground state. Sodium atom, neutral, sodium atom in ground state. Okay, from the outermost orbit of this atom, if you want to remove one electron, we have to supply some amount of energy. So this minimum quantity of energy required to remove the electron from the outermost orbit of a gaseous neutral atom, in the ground state. The sodium we have taken gaseous state, remember. In which state we have taken the sodium? Gaseous state we have taken. In gaseous state, from the outermost orbit, if you want to remove one electron, the energy required is called what? Ionization energy or ionization potential. Is that clear? So it is about what now here? The ionization potential definition. Is that clear, ma? Take the screenshot of this one. The sodium electronic configuration, we can also write what now? 2, 8, 1. 2 electrons in K shell, 8 electrons in L shell, 1 electron in M shell. Okay, what is the outermost orbit of sodium? Third orbit. What is valence shell of sodium? M shell. Valence shell is what? M. And outermost orbit is what? Third orbit. And number of outermost electrons, how many? 1. Number of valence electrons, how many? 1. That's why if you remove one electron from sodium atom, we get octet configuration. After losing this electron, the sodium gets what? Octet configuration. And as sodium is losing one electron, it becomes what now? Na plus. It becomes what? Na plus. So now sodium atom with the neutral charge is losing what? One electron. So what is happening here? Loss of one electron is taking place. Loss of electrons. So loss of electrons is called what, ma? Oxidation. Loss of electrons is called what? Oxidation. So sodium undergoes a loss of electrons, that is oxidation, to become which ion? Na plus ion. Na plus ion is formed here, and one electron is lost here. And this is called, Na plus ion is called uni-positive ion of sodium. Uni-positive ion of what? Sodium. So uni-positive ion of sodium is formed here. Cation is formed here. Cation with +1 charge. And what is oxidation number of sodium? 1. +1 is what? Oxidation state, otherwise oxidation number. Oxidation state or oxidation number of sodium, how much? +1. Like this, after oxidation, the sodium atom, the metal atom has been converted into uni-positive sodium ion, right? After oxidation. And sodium is undergoing what now? Oxidation. Sodium atom, metal atom undergoes oxidation. That's why the metal atom acts as which agent? Reducing agent. Reducing agent. The sodium acts as which agent, ma? Reducing agent. Not only sodium, any metal will act as which agent? Reducing agent. Why metals are reducing agents? Because the metals undergo oxidation. Metals undergo oxidation, meaning what? The metals lose electrons to become positive ions. And as positive ion is formed, this metal is called what now? Electropositive element. Metals are also called electropositive elements. Why metals are electropositive elements? Because the metals lose electrons to become positive ions. That's why they are electropositive elements. Metals are electropositive elements, and metals are generally reducing agents because the metals undergo what? Oxidation by losing what? Electrons to become which ion? Cation. This ion is called what now here? Cation. Positive ion is called cation. Okay, in the electric field, when positive charge and negative charge is there, the sodium ions, cations, will be attracted towards which electrode? Positive electrode or negative electrode? The Na plus ions have positive charge now. This positively charged sodium ions will be attracted towards negative rod or positive rod in the electric field. These Na plus ions will be attracted towards negative rod. The negative rod is called what? Anode or cathode. What we have to say? Cathode. Cathode is called what? Negative rod. So the cation will be attracted towards what? Attracted towards cathode or anode? Tell me. Attracted towards cathode. This cathode means which charged rod? Negative electrode or negative rod, you say simply. Negative electrode rod. So negative electrode rod. This negative rod, cathode, will attract what? Cation. Cation means which charge? Positive charge. The positively charged cations will be attracted towards cathode, the negative rods. Is that clear, ma? In electric field. In the electric field, the cations will be attracted towards cathode. Because cathode has negative charge, cations have positive charge. Unlike charges attract each other, positive and minus, negative and positive. Unlike charges attract each other. That's why Na plus is attracted towards what? Cathode in electric field. Is that clear? So it's about what now? Here, oxidation of sodium. Take the screenshot of this one. Now, this sodium atom, neutral atom, if it loses one electron, loss of electron, it is giving what? Na plus ion. Na plus ion, right? Now here, what is the electronic configuration of sodium atom? 1s2, 2s2, 2p6, 3s1. Here 1s2 first orbit, 2s 2p second orbit, 3s third orbit. In first orbit 2 electrons are there. In second orbit 8 electrons there. In third orbit 1 electron is there. How many outermost electrons? 1 electron is there. Now it is not stable. It is not stable. If one valence electron is present, if one valence electron is there, that must be metal. Remember. Now, after losing one electron, the sodium has been converted into what? Na plus. Now, Na plus has how many electrons, ma? Only 10 electrons. Na plus has how many electrons? 10. But sodium atom has how many electrons? 11 electrons. Sodium atom has 11 electrons, but sodium ion has 10 electrons. For 10 electrons, how to write electronic configuration? 1s2, 2s2, 2p6. Okay, here 1s2 first orbit with 2 electrons and second orbit with 8 electrons. Now 8 electrons in the outermost orbit now. 8 electrons in the outermost orbit is called what? Octet configuration. What is called? Octet configuration. Octet configuration means inert gas configuration. Octet configuration is nothing but inert gas configuration. What is inert gas configuration? Otherwise octet configuration? The presence of 8 electrons in the outermost orbit. In second orbit, there are 8 electrons, 2 plus 6, 8 electrons. Here, sodium atom has a nucleus with some positive charge, plus 11, you take suppose, plus 11, and here first orbit, second orbit, and third orbit. 3 orbits are there here. In first orbit, how many electrons? 2 electrons, 8 electrons, 1 electron. In sodium ion, how many orbits are there around the nucleus? Around the positive nucleus. What is the charge here? Plus 10, plus 11, plus 11. 11 will be nuclear charge. Number of protons in the sodium atom 11. Number of protons in the sodium ion also 11 only. In the sodium nucleus, Na plus nucleus also, how many protons will be there? 11 only. 11 protons means positive charge will be plus 11, suppose nuclear charge. Now first orbit and second orbit, 2 orbits only there. In first orbit, 2 electrons there. In second orbit, 8 electrons there. Now outermost electrons, how many? 8 electrons. 8 electrons in the outermost orbit of Na plus. But in any atom, 1 electron in the outermost orbit. Right, ma? So 1 electron in the outermost orbit, 8 electrons in the outermost orbit. So this octet configuration gives stability to this Na plus ion. Why sodium has lost 1 electron here? To get what? Stability. So octet configuration is what? Stable. Stable configuration. Stable electronic configuration. As octet configuration is stable electronic configuration. EC stands for what? Electronic configuration. Octet configuration is stable electronic configuration. Therefore, the Na plus gets what? Stability. Is that clear, ma? Now, this sodium absorbs some amount of energy in here. The sodium atom absorbs what? Some amount of energy. This energy absorbed is called what? Ionization energy. So, ionization energy is absorbed by this sodium atom, and sodium atom has lost 1 electron to become what? Na plus ion. So, this amount of energy required by the neutral atom to remove 1 electron from the outermost orbit is called what? Ionization energy. The same thing is also called ionization energy 1. IE1 means first ionization enthalpy, we say. First ionization enthalpy, or simply we say what? Ionization enthalpy. Simply what we say? Ionization enthalpy. So what is here? So the energy required is called what? Ionization enthalpy 1. Okay, so the same thing is called what? IE1 or simply IE. First ionization enthalpy. Is that clear? Let's take the screenshot of this one. Now, see here. Now, sodium already lost 1 electron to become Na plus ion. Okay. Now, here it is called, the energy required is called what we said, IE1, or simply what we say, IE, ionization enthalpy. The same thing we can also write IH1. Delta IH1 means first ionization enthalpy. What we say this one? First ionization enthalpy. First ionization enthalpy. Is that clear now? So first ionization enthalpy or first ionization energy we can say here. It is IP1. What we say? IP1 or IE1. P means potential, ionization potential, IP1 or IE1 we can say. Now uni-positive ion is formed. Now from this Na plus, again if you want to remove 1 more electron, from Na plus, suppose, then the amount of energy required is called what now here? Ionization energy 2, IE2 we say here. IE2 we can say, or IP2 we can say, second ionization potential, or we can also say what? Delta IH2, or IE2 or IP2 will be called what now? Second ionization enthalpy. So the amount of energy required, is called what now here? Second ionization enthalpy. This is called uni-positive ion. What is called? Uni-positive ion. From uni-positive ion, if you want to remove 1 electron, okay, the energy required is called what? Second ionization. So this much amount of energy is required to remove electron from Na plus. Now when you remove electron from Na plus, what will be forming? Na plus 2 will form. Na plus 1 loses 1 more electron to become what? Na plus 2. That means from Na plus, if you want to remove electron, we have to give large amount of energy. Why? Take here, suppose here Na plus electronic configuration, tell me. Electronic configuration 2, 8. Here electronic configuration is what? 2, 8, 1. Here 1 valence electron is there. Here 8 valence electrons there. 8 valence electrons means what now? Stable electronic configuration. Stable electronic configuration. To remove electron from this stable electronic configuration, we have to supply large amount of energy. Here from 8 electrons from octet configuration, if you want to remove electron, it is difficult. It is not easy. So to remove this electron from octet configuration, we have to give large amount of ionization enthalpy. So the ionization enthalpy to IE2 value is always greater than what? IE1. Okay, IE2 value will be greater than what? IE1. Why second ionization enthalpy is very high here? The reason is that in case of second ionization enthalpy, we are removing electron from unipositive sodium ion. Unipositive sodium ion, Na+1, has octet configuration. Due to this octet configuration, stable configuration, it is difficult to remove electron from 8 electrons. That is why we have to give large amount of energy here. When you supply large amount of energy, what happens? IP2 value will be greater. So IE2 will be greater than IE1 always. The reason understood here. Ionization enthalpy 1 indicates what? First ionization enthalpy means what? The energy required to remove electron from neutral atom. It is what now here? Neutral atom. From neutral atom, if you want to remove electron, the amount of energy given is called what? IE1. From uni-positive ion, if you want to remove electron, the amount of energy given is called IE2. That's why IE2 value will be greater than IE1. Let's take the screenshot of this now. Now take some metal, suppose. I'm taking one metal. It is neutral metal atom, suppose. From this already we removed one electron and we got M+. M+ means what? What I said? Uni-positive ion. Uni-positive ion we got here. Uni means 1. +1 na here. +1 means uni-positive ion we got here. And here how many electrons lost? 1 electron lost. This energy required is called IP1. IP1 means IE1. First ionization potential is given to this metal atom. Then we got M+. Now again, from this M+, what we can get? M+2 we get. M+2. This is called di-positive ion. Di-positive ion. Okay. Now we got di-positive ion by removing electron from uni-positive ion. Right, ma? Now here, to this uni-positive ion, how much amount of energy is given now? IP2 is given. IP2 means what? Second ionization potential. So IP2 energy is given to what? M+ ion. To get converted into what? M+2. M+1 is converted into M+2. For this conversion, how much amount of energy required here? IP2. So second ionization potential is required here. Is that clear? Again, if you want to remove one more electron from this, to get what? M+3. M+3. M+3 is called what now? Tri-positive ion. Tri-positive ion. From M+2, if you remove one more electron, it becomes what? M+3. M+2 becomes what? M+3. If you remove one electron, plus charge will increase. Means what here? +2 becomes +3 if you remove one electron. And +1 becomes what? +2 by removal of one electron. And 0 becomes what? +1 by removing one electron. That is, for the removal of every electron, +1 charge increases. +1 charge increases. So here, M+2 ion, di-positive ion, gives rise to tri-positive ion. Here, how much amount of energy given to this M+2? To the M+2 ion, how much amount of energy is given, ma? IP3 or IP2? IP3 is given here. What is given? IP3 is third ionization potential. So third ionization potential is given to M+2 ion. The amount of energy given to M+2 ion to remove electron is called what? IP3. And the amount of energy given to remove electron from M+1 is called IP2. And the amount of energy given to the neutral atom, the amount of energy given to the neutral atom to remove electron is called what? IP1. So IP1 is given to neutral atom. IP2 is given to +1 ion. IP3 is given to +2 ion. Still, if you want to remove one more electron from this, then we get what? M+4. M plus 4 is called what now? Tetra positive ion. Tetra positive ion. If you want to remove one more electron from M plus 3, here we have to supply how much energy? IP4 or IP3? IP4. So the amount of energy given to M plus 3, the amount of energy given to M plus 3 ion to remove one electron is called IP4. So the amount of energy required to remove electron from M plus 3 ion, tripositive ion, is called what? Fourth ionization potential, IP4. So like this, IP1, IP2, IP3, IP4. Now what will be greater than what? Tell me. IP4 will be always greater than IP3. IP3 is greater than what? IP2. IP2 is greater than IP1. So this concept you have to understand here. Is that clear? No? For the given ion here, for the given metal atom, what are the values here? IP1, IP2, IP3, IP4. If we take, what will be highest value? IP4. Which will be least? IP1. Is that clear? So this is about what now here? The ionization potential concept. Okay. Take the screenshot of this moments. Yeah, now see here. Now, suppose I'm taking here M0, M plus 1 ion, M plus 2 ion, M plus 3 ion, suppose. Among these, which will be smallest in size? Tell me. Smallest sized what among these species? A largest species is what? Neutral atom. The smallest species is what? This one. Which is smallest here? The M plus 3 will be smallest. If the charge here plus 1, plus 2, plus 3, when the charge on the metal atom increases, when the charge 0 to plus 1, plus 1 to plus 2, plus 2 to plus 3, when the charge increases on the metal atom, what happens to the size? The size will decrease. The size will decrease. Here the energy given, the amount of energy given to the neutral atom to remove electron is called what? IP1.